In this next video, we are going to proceed with some more practical examples that are related with the ambient assisted living. So we will see first we are going to generate our own stream of data. Those data will be in the JSON format. So therefore, before we start doing anything on the coding side, we have to include some more dependencies into the POM.xml file for the Apache Flink application. So over here, I have added these two dependencies. The first one is oraga.json, and this one I will use it in order to create JSON objects, while the second one is com Google Code JSON, and I will use this one in order to serialize and deserialize JSON objects over here. But I will use this one probably later. So we already saw how to add a source, a simulation source in our application. For example, this was the one that we added, first example data source. So now we will add one more, and this would be, we'll name this Java class into sensor data source function. And as we previously wrote, the source function should implement the source function interface. We want this to generate strings, okay? Because when we receive the data from some sensors, they would be in the lowest level possible. They would probably even be in bytes, and we will have to serialize them into strings, and then maybe serialize them into some other objects of Java classes. So first, as I said, let's start with having it as a string. Maybe later we'll have it in something else. Uh, so what will be the purpose of this? As I said, in the run method, we are going to simulate a stream of, let's say, for example, 1000 sensor data again, or let's maybe do it more. So we will definitely have a for loop over here that will iterate all all in total n times. Of course, we are again going to need that random object that we declared previously, and this random object will help us to sleep for a while. In that way, we will generate some kind of delay between the messages, so they won't be sent instantly, all of them. Uh, what is the goal over here in the run method? So the goal over here is we want to generate a JSON format message, and the JSON format message would look something like this. So we will have a sensor ID over here, some sensor ID. This can be both string or numerical, but let's keep it as a string maybe. So let me add over here this. Then we will have the sensor type. This would also be a string. So for example, in just for the sake of this exercise, we will use some four sensor types, one for temperature, one for carbon monoxide, one for maybe pressure in the room. Let's make it like this so we don't use a lot of letters, and one for humidity. So these are the possible values over here. And most importantly, our sensor is going to have a numeric value. This value can be some number type. It can be an integer. It can be a double. We'll make it a double for the purposes of saving the data and not losing any information. And last but not least, we will have definitely a timestamp where this can be a local date time object, or it can actually, when we're working with this kind of real-time stream engines, we might want to use we might represent the local times, the timestamp as a long variable, which represents the number of milliseconds passed since January the 1st, 1998 or 97, I'm not sure. So this is actually how Flink is extracting, how Flink is keeping track of the timestamp of the data in this format. So we might even go directly into this. to make things easier for Flink. But again, this doesn't need to be the use case. So timestamp format can be various, and we as programmers have to handle it. We'll see how we can handle it. So maybe we will go with both scenarios over here. Both with we'll try it with local datetime and with uh, and with long as a variable. Um, okay, so for this over here now, the sensor ID would be, let's go over here and create let's create a map over here where the key would be a string. This would be the sensor type, and the value of the map would be a list of integers. Those list of integers would represent the corresponding sensor IDs for all of these four types of possible values. So let's do it that way maybe. It would be a hash map. Let's sensor IDs by sensor type. This would be the name of the map. Let's even maybe write a constructor over here for this class where we are going to fill these sensor IDs by sensor types with some values. So for the temperature, let's say we're going to have the sensors numbered 1, 2, 3, 4. So temperature, we are going to have, not sure if this is going to work, but let's give it a try. 1, 2, 3, 4. Yep. Then for the um, carbon monoxide, we're going to have 5, 6, 7, 8. Then for the pressure, we're going to have, let's say maybe 3 sensors over here or 2, so 9 and 10. And lastly, for the humidity, um, we will have um, we will have 11 and 12. Okay. Yep. This looks okay. Uh, maybe we can even put some kind of thresholds for all of these sensors. So the purpose, just to state, the purpose of this function would be to generate random data over here, and we would like to generate this random data in for the sensors. We would like it to be reasonable data, not to be some kind of data that's way overhead. So maybe, yeah, let's do it. Humidity, pressure, this would be the sensor IDs, sensor types, and now we would have to do something about the values. Maybe let's create a map of string and double, and this would be the mean value by sensor type. Also, we would have one for the max value. This would help us to have the correct ranges for the sensor types. So for the over here for the mean, let's put for the temperature. Let's have it something of this is for a room temperature. Let's make it like 20 Celsius. Needs to be a double. For the carbon monoxide, not sure for this one. Maybe we can Google it. 0.5 till 5. Okay, let's do it that way. 0.5. So let me just remember the max is going to be 5. So everything above that can be detected as anomaly. The minimum value for the pressure would be, let's see, pressure normal values. Standard temperature and pressure. Let's see just which unit are we going to use. Kilopascals maybe. So let's go from 100, actually from 101 till 100 till, I don't know, till 103, something like that. Okay, and the mean value by sensor type for the humidity. Take a look again. 30 till 50%. Okay, 30.0 till 50. So let's do the same for the max values. So we'll do the same for the max values as well. So for the max temperature, let's go till 30 because everything above that it's really really hot. For the let's do the here lower 15 maybe. Someone likes it cooler. This would be 5.0. This would be 103.0. This would be 15.0. Okay. Yeah, I think this can do it for the moment being. We'll definitely need some kind of method that will generate for the sensor value over here. It will generate random value in the ranges. So random value in the ranges min and max. Okay, so private double generate random value double min double max, or maybe we could do it by sensor type. Yeah, let's do it double min and double max. If we need, we can refactor the code later. So random has next double, and this next double is actually going to be a double in the ranges of, it will be a double in the ranges of 0 and 1, if I'm not mistaken. Yeah, next double. Let's just give it a try so we can be sure about this. Okay, let's test this in the, we'll write the main method just to test this. I think, yeah, if I'm not mistaken, this will generate a random value between. Okay, we need to include the dependency with the provided scope for this to work. Yeah, it's something between 0. So we have to scale this up in a value that would be between the min and the max value. So how do we usually do that scaling? So for example, if we want to scale something between 0 and 1, we can use the formula equals to max minus the number. Actually, sorry, number minus the minimum. divided with max minus the minimum. So we can, let me just check that, min max scaling. Yeah, x minus the minimum divided with max minus the minimum. So we can convert this into something that it would be more in our case. So we have the scaled value now, that's this random next double. We have to convert it into a number over here. So the scaled, this would go below. So number minus the minimum is equal to the scale divided with max minus min. Max and min, we have them over here. So the number itself will be equal to the scaled, that's the random value, divided with max minus the min, plus the min value. So this is how we can calculate a number between min and max with random next double. So let's do that. So integer, let's declare it as scaled over here, random next double. And we will calculate the original number, the value actually. Let's do it this way. The value will be as, so the scaled divided with max minus min plus the min value, and we will actually return this value so we can go in line. We don't have to, this can be directly a return value. Let's give it a try now and see what are we going to get. Is it going to be a value from 0 till 10? Okay. Let's make it from 5 till 10. Let's see if that works. Yeah, I think it works. It just gets us some really low values all the time. Okay, yeah, we can work with, I think we can work with this. It's not a big deal. Yep, it's just returning all the time. So next double, this might seem to be equivalent. The next pseudo-random uniformly distribute value between 0 and 1. Okay, these numbers will increase all the time because we will be using the same random object. So I think we won't have much issue with it. Five and 7, let's say. It's always generating this 549, 536. Okay, as we can see, it's varying. Okay, then if this is the case, I'll get back the temperature here to 20. Okay, so we have this now, this util that will help us to, actually I have a mistake, I have a typo. So this would be multiplied over here. This goes from below goes to above in the fractions. Scaled times max minus min. Yep. And then and then the min goes as a plus over here. Yep, this should work better. Let's test it now. So 5 till 7, we should get at least a 6 or 6 point something. Yeah, now it looks better. Definitely, we're getting numbers in the whole range. Perfect. Okay, so now we have this one. Sounds good. And let's then we can proceed with the generation of the logs. So for this JSON object, as I said, I'm going to use this JSON object class. I need to import this first. Okay. Yep. Here is the import. It got imported automatically. So let's give it a start. First, we have to select a random sensor type. Okay, so that's the first step. Why? Because the sensor ID and the value, both of them depend on the sensor type. So random sensor type. We are going to select the sensor type. We could do it from any of these three maps, from the keys of that map. Okay, so let's do it this way. Let's see if I can do it that way. So sensor whatever dot keys. Um, I want it as a list over here. Yeah, let's maybe declare a list. So it would be much easier to work with list for this scenario. Sensor types. And here we can have directly a list of temperature, carbon monoxide, pressure, and humidity. Let's do it that way. So I can directly select a random element from this list, sensor types, get, so we have to put the index over here. The index will be between 0 and 3. And how can we get a number between 0 and 3? So we can say random next integer, and the bound of this integer would be the size of the sensor types list. That would be 4, and random next integer of 4 will generate 0, 1, 2, or 3, which is exactly what we need. Then we are going to get a random sensor ID. How are we going to do a random sensor ID? So from the sensor IDs by sensor type, we are going to get the list of sensor IDs for the random sensor type that we have generated previously. This is a list. Let's maybe put it in a list because we are going to need some operations with the list itself. So the sensor type, random sensor type, will be generated as from the sensors list, sensor IDs. We are going to get, again with the same logic, the next integer of the sensor IDs dot size. If all of them had 4, it would be easier, but we've put 2 in some and 3 sensor IDs in some sensor type, so this would be better. Sensor, random sensor ID. Okay. Then we have the value. So the value has to be selected in a given range. So let's extract the max range from the max value by sensor type, random sensor type, and the min range would be from the min value by sensor type, get random sensor type. So the value, the random value for this measurement would be as used with the method generate random value with min range and max range over here. And of course, for the timestamp, we are going to go again firstly with local date time. And this is going to be local date time dot now. And I think we have all the 4 things that we need. So we have a sensor type, a sensor ID, a random value, and the current timestamp. So now we can proceed into creating this JSON object. So object put, the JSON objects are just like a map, so we can use this put method and to put various type of values into the JSON. So first we have sensor ID, and for the sensor ID we are going to put the random sensor ID. Then we have the sensor type. Here we're going to put the random sensor type. Then then we have the value. The value will be a double. That's the random value. And lastly but not least, we have the timestamp, which is going to be the current timestamp to string. Let's do it this way. So when the object is created, we can get its to string notation and send it to this source context. So dot collect object to string. There it is. And of course, as we said, we are going to sleep for a while all the time. Random dot sleep, random dot next integer. Let's do it less here. So maximum till 1 second. We want it to be a more frequent measurements, or maybe 150 again. Okay. So this will actually be the whole process of this random generator for our data. And let's test it. Let's go in this first example. And here I'm just going to change the source function. So instead of first example data source, I'm going to use sensor data source over here. Let's optimize all of these imports. We don't need them. And let's see what will happen now. Are we going to get the same things that we want? Okay, they're starting to coming out, and they are, I think, pretty much what we imagined. So temperature 23, pressure from 101 to 103. The humidity looks good as well. The pressure looks good as well. Perfect. Yeah, I think this is okay. So let's also now add one more thing over here. For example, we would like sometime to have anomaly value over here. So how can I do an anomaly value? Some of the values are going to be anomaly. So let's say over here at this random value, I'm going to say, for example, if n modulo 50 on every 50 records. So on every 50 records. And also, besides doing that, we will have a random dot next boolean. So if this is true, so in this case, let's just declare the value over here. Okay, so in this case, the random value is going to be the max range plus some random next integer. We can do integer of 10. So this would be an anomaly, maybe 20, something bigger. And plus 10. Why plus 10? If I do it this way, the random values will be generated in the range from 10 till 29, actually. Because if I don't have this plus 10, the random values could be from 0 till 90. So if the random value is 0, we are actually not doing any kind of anomaly over here. So this way they would be from 10 till 19 plus 10, that's 29. So yeah, this would be in case of an anomaly. We'll decide if an anomaly is going to happen on every 50 records, or maybe do it less, 25. Let's do it. If not, so we can do this in the else statement. If not, the random value will be initialized on the same way as before. Let's do it this way. Uh, so let's also print over here anomaly was generated, so we can know when the anomaly happened. We'll get something on the system out. Okay, these are first some logs that we can simply ignore. Okay, anomaly was generated. This shouldn't be the case, but yeah, actually probably it's not synchronized with all of the time. The output is not synchronized. So let's see, for example, carbon monoxide 21, humidity, here it is 71. Okay. 49 for the temperature. Yeah, okay, so we have some anomalies over here, but maybe we should do them less frequently. Stop and rerun. Oh, this is the mistake, not n. The counter. N is 100 and n is 2000, so n will always be divisible with let's stop it. I think the change was not included. So if I is modulo 25 again, yeah, so n is 2000, 2000 modulo 25 or modulo 50 is always 0. So it was actually generating variables anomalies on every whenever the random next boolean returned true. I think we should now see a scenario where it will not generate that often anomalies. Yep, looks so good. Now we have one for the pressure. It got till 115. Yep, this looks okay. And this happened after nearly 25 records, just as we have imagined it. Um, okay, this looks good so far. Let me just give you one more. We have one more anomaly for the carbon monoxide, I think. Yep. So one thing that I said that I want to mention over here as well is that in some use cases, the timestamp in Flink actually is expected to be a long number. So let's try and do that here in the random generation as well. So instead of putting the timestamp to string over here, we're going to use epoch milliseconds. Let's see, how can I get that? Time or local date time to instant, I think we have. Nope. Let me just Google it quickly. Local date time to milliseconds. Or we can actually use system current time milliseconds, or we could make it first as a zoned date time. Yeah, and then to epoch milli. So the current timestamp to at zone actually. So for the zone ID, we're going to use the, let me see if I have the current system default. We'll use hour, and then this will go to epoch seconds. Let's take a look how will that look. Yeah, here we have it. Here we have it. So if you go to a epoch time converter, you can see that this is today's date, March 29th, and at 11:04, actually, yeah, my time. Okay, this would be it for the current video. This would be it for the current video. We have successfully created our source data. We have simulated a streaming data that we're going to use. We could make the frequency faster if we just decrease this sleep time. Let's take a look. How will that look? And after that, we can start playing around with all of the options that Flink is allowing us to use. As you can see, the logs are much faster now. Okay.